Okay. So just so that we have this. Okay. There we go. And we have been talking about our agenda today, which we're going to cover at week 8. We'll cover the slides 1 through the core slides, which is really about the control phase, standardization, monitoring, control plan. Then we'll cover a couple of special topics, just touching on them. We're not going to go to the depths. 2 technical ones, optimization and queuing. Sometimes these are called advanced lean. They come from something called operations research, which was developed in the 1940s to defend against the Nazi threat, believe it or not. And there was just a movie about this, about Alan Turing. It wasn't specifically about operations research, but it was developed in all sorts of for reasons of how can we deploy our production? How many ships should we build? How many submarines should we build? How many tanks should we build? How many planes? All that kind of stuff. So you can see why it's answering questions about that. And the idea is with operations management or operations research is you're answering questions that are largely, I want to maximize or minimize something given a bunch of constraints, right? I only have so many people, I only have so much money, and so I think you'll find that that's real applicable. And then we're also talking about DFSS, which is a design, if you have design projects in Hoshin kanri. All right, and in Hoshin kanri, the impetus for this is, many places they're trying to do too much, too many projects, and I guess what I would say is they have too many unimportant projects. So maybe you would agree with me, I hope you would, that many companies aren't really good at prioritizing what they need to do and what they don't need to do. And so what Hoshin kanri does is it does that exactly. It helps you find out what you need to do. It helps you build your to-do list. And this is usually for projects, your to-do list and your not to-do list, which in some ways is more important than the to-do list because, again, you've only got a finite amount of resource. And anyway,
does that use some kind of a prioritization matrix?
It does, yeah, it does. Mm-hmm. It uses a prioritization matrix, and it takes a two-pronged approach. It takes it takes things where you put into business as usual, and I'm going to use our tools right here, and then I'll just say need to improve. So it helps you develop plans for these. The plans for these are essentially now. This is a statistician black belt's interpretation, okay? But these are situations where you essentially want to put on a control chart and manage out of control conditions. Business as usual is kind of this. We're not trying to make this go improve. We're not trying to make it get worse. But we need to manage out of control conditions, right, on our key variables, whatever the key are, on our KPIs. On the other hand, over here are things where instead of looking at a control chart, what we'd want to look at is we want to find some way of maybe improving those over time, and we have stated goals that are maybe given by the customer or by management, targets that we need to hit, and I'm going to use a different color. Whoops. I use a different color on this one. Maybe this is oh, look at that. All that work that I put to do a different color, and it didn't give it to me. Let's try it again. There we go. Where this is a management goal, right? So over here, we're simply trying to manage the process. This is really manage, and this is really improve. And the interesting thing is, I think with Hoshin is there's there's an assessment period where you start to build this to-do list and to not to-do list and deploy it into business as usual and improve. And basically, where everything ends up being you want to put everything over here. But you just don't have the resources, and it forces you to see that. And so it forces you to prioritize and start to build it and to manage and improve. It's great. It's not something I want to get too deeply into right now because there's no way we can cover it all. But I did want to talk it through. There is a video. I encourage you to have a look at it and so forth. And as you might expect, this is a Japanese technique. It comes from the Japanese, and it comes from I think one of these words is a compass, like north, east, west, and south, and I think the one of the words, and I don't remember which, is it refers to the pointer. So it's something like shiny metal pointer on compass or something like this. But that's what Hoshin kanri means. It's a navigator. It shows you the direction. Okay. Before we get started in the regularly scheduled program, what questions do you have from last time? Last time we covered measurement systems and all that kind of good stuff. Okay. All righty. So let's go into the last slide. We're going to just start in our book, and I'm going to try and stick actually a little bit with a regularly scheduled program today. We're going to be covering, like I said, primarily the topics in control, and then I just want to introduce you to these two things that are there. I think you might find them interesting or helpful, and if you don't, it won't take that much time. So, but we want to really finish this up, and the first part is really just to ground us. It's really, this is the heart of control. Now, the point of this, as we go through this, you'll see, geez, we've covered a lot. How many slides did we cover on DOE, and how much time did we spend on regression and stuff like that? I think that reflects, for a lot of people, the difficulty of those topics and the technical details of those topics. However, writing a good control plan, taking time to write out the documentation, that's at least as important in terms of getting results. It's not all that complicated, but it's at least as important, and it's at least as difficult because it deals with behaviors of people. So the things that we said about behavioral analysis as well, I think is kind of important. This might be the time where you take out the ABC analysis when you think about how I can reinforce. If you can do it positively, that's what you want to do. And positive, remember, doesn't necessarily mean providing people with attaboys. Good job, everybody. It's simply giving people feedback that's going to increase behaviors that you want to have happen. So, for example, if you want people to use a standard operating procedure or a policy and procedure that you just developed, one way to positively reinforce that might be to have everybody, have it posted on their cubicle. I just totally made that up. It might be a terrible idea. But that way, the first thing that they're looking for is that. Or an audit where you have somebody remind them that they're supposed to, like I once had as you know, I once ran a call center in California. Well, I was responsible for somebody who ran a call center in California. And so, when I did my audit of it, I was shocked to find that everybody had a different closing technique and there was no script. So I dragged them kicking and screaming to a script. And I said, now that doesn't mean that you just read the script, okay? We all need to be comfortable understanding what's in the script and what's not. But if you're not ending the conversation with the doctor's office asking for access and closing with them, you're not doing it. You're not doing your job. You need to be able to do that. So I had to have people monitoring that and going in and asking people and just reminding people. It wasn't in a negative way. It wasn't in a nasty way. But that's a positive reinforcement for the behaviors that we want. And it's not necessarily a touchy-feely nice thing, but it is a positive reinforcer. Okay. All right, so let's have a look at standardizing. So or at where we are in this. So when we complete this section as well as the others, we'll be able to apply error proofing. So I want to talk about error proofing. I'm also going to talk about standardization, and we'll talk about two other things that you can think about: 5S and designing a visual board as well. So these are some techniques that we know help to standardize and standardize procedures and behaviors. So this is what we're talking about. We're in control. We've already defined our project. We've measured it. We've come up with what's wrong with it. We've enacted improvements, and so we've already done that. And we've also evaluated those improvements so we know that they work. Now that we know that they work, we want to make sure that we institutionalize the changes that we know work. Okay? We're not paving cow paths. We're improving things that we already built new roads that are going to work well. So we want to make sure that we get them. I'm not going to talk about why we need to standardize, but I do want to talk about this. You can read through all of that, but this I want to make absolutely clear. Standardize the things that need to be standardized, star, star, star. Not everything, okay? A lot of people talk about Six Sigma as being all about standardization. Well, we don't need to be doing all the same thing if some of those actions don't mean anything at all. For example, I had a company where I worked at a company where they had where they processed loan applications, among other things, and a financial services company. And they had a shift. They had people working two different shifts, a morning shift and an afternoon shift, and they each used similar space. So one of the things that they found out was there was a lot of waste and confusion and rework because when the new shift would come in, they worked on wrong orders. It's actually pretty simple. And so one of their improvements was to have, before the other person went out, they had to get the inbox in order and the outbox in order, and they had to make clear what was the in-process work. All that makes sense to standardize. Absolutely want to standardize that. However, they went so far as saying, you couldn't have plants in the office, and you had to, and you couldn't put up pictures of your children and family, and you had to have the stapler in a certain place, and people hated all those things. So just make sure that you standardize the things that matter. You don't want to fight battles that have no point in winning. What does that mean to us? Well, what it usually means to us is that we need to make sure that we connect it with the root causes and our improvements that we found. If we found that there were, a couple of different key inputs that we found were affecting it, standardize those key inputs. Don't try and standardize the ones that didn't matter. If you found out that there were a couple of different places in the process that you really needed to fix, standardize those things. Don't try and standardize the whole process. If you did find that there were issues with the whole process, of course, then like in some lean problems, maybe you want to institute pull control over the whole process, but that's a bigger thing to do. So just keep in mind, keep your standardizations targeted. I'm going to move on. I think there's other stuff that's interesting and things like that that you can talk about, writing policies and procedures. But unless you have questions, I'm going to move on. I'm going to assume that that's pretty straightforward. And if it's not, please ask. We're good? Okay. I do want to also talk about something called error proofing. Now, why the heck are we talking about error proofing now? And isn't that just DMAIC anyway? Well, error proofing is something that's slightly different. And it's also called mistake proofing, which I like. It used to be called idiot proofing, which I hate that because you're calling people idiots. I don't like that. So anyway, and it's also called, in some circles, poka yoke. and it just means to prevent errors, a Japanese term. Okay, um, and so that's that. So what is it? Well, what it is very often when you make your improvements to a process, um, you'll find that when you pilot your improvements, they don't always work perfectly. There are little tweaks that you might need to make here or there. And so error proofing is kind of a way of thinking about how you could make those little tweaks and a structured approach on how you do it. So that's all it really is. And I don't want to make it anything more than what it is. But one of the reasons why we're talking about it here is that in a lot, I have seen companies that sort of have company-wide error proofing. And nothing terribly wrong with that, but if we're doing a DMAIC process, let's suppose that we were doing a DMAIC process and we went ahead and we tried a bunch of, let's say we tried a bunch of error proofing here in M. We tried a bunch of error proofing here. Like we put in some fixes or whatever, and let's say we put a bunch of fixes right in here to here. Okay, we spent some time and energy doing that, and some time and energy working on these error proofing, some time and energy. Well, let's suppose that later, when we were doing a root cause, we essentially found out that this step of the process was not needed, and our improvement was to eliminate this step of the process altogether. Now these error proofing measures are looking kind of silly, right? So that's why we want to put them at the end instead of the beginning of the process. Okay, so that's why it appears here. It is a general business technique that you can use in an area if you're not doing a Six Sigma project. So, in that case, you know, you wouldn't be doing a DMAIC and possibly doing a transformative improvement. Okay, so how does it work? Oops, before we go into how it works, one of the things I love hearing is things like, oh, well, there's always human error. There's always human error. Or, it's good enough. It's good enough. And when you run into those, or the problem is, oh, it's just human, you know, whatever. It's just human error is our problem. Whenever somebody says it's human error, here's a way of maybe breaking through that, right? So these are also very rich areas where there's often a lot of errors that are made. Anytime where there's a lot of symmetry in either a product or a process, or there's a lot of asymmetry. So let's think about symmetry for just a second. Let's say I'm filling out a form. I'm an employee. I have to fill out a form. The one side of the form is almost the same, but not quite as the other side of the form. That lends itself to somebody making errors because they're not thinking on the second side of the form. So anytime there's symmetry or asymmetry, you ought to be looking about, is there something that we can put in to prevent that error? Anytime there's very high volume, maybe error proofing might work well. Anytime where there's constant repetition, people can sometimes get very bored. Poor environmental conditions, boy, that is something that I think is, if I were going to star one of these, I would star this one because I see these sort of things a lot. I have somebody working in an environmental condition which is just not that good, and which may, by the way, be the cultural situation, and they're just going to make errors. One of these examples was I did some work with a company called I won't give the company. They were a medical provider in oncology, and they were pretty big. They were a nationwide employer, and they had me go and assess some things. And one of the projects that we thought of right away was when we went in and we observed. You know, these are a number of highly paid pharmacists, a number of highly paid doctors, and you've got cancer patients coming in. You've got technicians, a lot of oncology nurses, and for this particular facility, which was one of their biggest ones, they had one single scheduler. And not only did she schedule, but she handled people at the front desk. And boy, if she wouldn't have been able to get the job done if she had 8 arms. I mean, it was just ridiculous. Watching her, she was so overtaxed, and she was just making errors on the fly. You could just tell. And it wasn't her fault necessarily, but it was just very clear that this was an environment that she wasn't going to thrive in. And they were just going to make a lot of errors. So I would either attribute that to poor environmental conditions, or it wasn't really even high volume. This was expected volume. But they're not, they're not spending the money where they need to spend a little bit of money. Poor capacity management. Anytime where there's a lot of adjustments in mixed or many parts, many steps to a process, that's tough. Or infrequent use, and that's another one that's pretty big. If you're not using something a lot, it's a ripe place for errors to occur. And that happens to everybody. It happens to me. If I haven't done something in quite a while, like some of the homework problems. There was one problem with the truck springs that somebody asked me about, and it took me a while. This was in DOE, and it took me a while to figure out my bearings. It just takes a little bit of time. If I had to do it right on the fly, I didn't do it perfectly. So there you go. All right, so remember those. They're helpful. Okay, so here's the idea in error proofing. If you find an error that you want to get rid of, think about it this way. Number 1, design it so that you cannot do it incorrectly. Number 2, design it so that you can only do it in one. If you can't do it this way, design it so that you can only do it in one way. Or the third way, if those two lend themselves to not being able to be done, label it or find a way to make it so that if it's done incorrectly, the person who does it incorrectly gets immediate feedback. Okay, so an example might be, I don't know if you guys are as, I'm going to have to deal with this very soon because I have a 15-year-old, but he's going to turn 16 and he's going to drive. So one thing when he drives, I'm going to worry about him because I worried about myself doing this. Hitting the back of the garage when I park the car, when somebody parks the car. So let's suppose I wanted to prevent somebody from hitting the back of the garage when they park the car, right? So here's my car, and well, that's not a very good thing. And here's the garage, and I don't want to hit into the, I don't want to hit into the wall. So there's a number of different ways I could do that. The first, if I were trying to error-proof that, maybe the first thing I would think of would be, I don't know, erect a barrier at the back, maybe a cement block or something like this, such that the car can't hit the back of the garage. Now that might not be practical, it might be too expensive. So instead of that, maybe what I would do is I would design it so that it can only be done one way, so that he's not maybe parking too far to the left or too far to the right. It's not so clear that I can figure that one out. Maybe I'd have to give training or something like that. But a third way that I might do it, if those two don't work, is I might hang, and those of you who have been through this, you know what I'm talking about. You hang the tennis ball from the ceiling, so that when the tennis ball hits your windshield and bounces off, you know you're going too far. Okay, but essentially that's using the method number 3. You hang the tennis ball and give feedback like, uh-oh, you're too far. And you can see that's not going to work as well if somebody ignores that, or if somebody is already going too fast, they're going to hit the back of the wall anyway. All right, so those are just some kind of examples. So what are some examples of error proofing? Well, here's a few of them. Garage doors that sense objects and don't close, so that if somebody walks under, say a baby or a kid walks under a garage door, the garage door is closing, it senses it, doesn't close. Grounded electrical plugs, they have 3 prongs, so you can only plug them in one way. You can't plug them in the wrong way. Locks that can't lock without a key. Computer restart with Control-Alt-Delete pressed at the same time, and so forth. So let's take a second. I want to just take a second, and I want all of you to come up with. Let's do this together. if all of us come up with an idea from, how about in your kitchen? What's an example of error proofing? And then with computer, and then at work, what would be something that you could do to error proof, or maybe already has been done? So let's take 2 minutes, just write down one example, each of you, and we'll kind of go over there. What could you do to error proof there, or what has been done to error proof? And just give me an indication when you're ready. Okay, how we doing?
I'm done.
Okay. Well, let's go over it, and let's try the first one. So for in the kitchen, I'll give you mine first, so that we're on the page. So I chose the coffee maker.
Oh, that's what I had.
Is that
Automatic shut off.
automatic?
Yeah.
Exactly, auto shut off.
Yep.
That's a lifesaver for me. All right, Steve, what was the one that you had for the kitchen?
I have something similar. At home, I have an electric kettle, water heater, and once the water is warm and it heat up, it turns itself off.
Mm-hmm. That's good. Yeah, I have burned a number of kettles. I'm not good at that. All right, and John?
I have a warning light on my oven that tells me which burner is on.
Oh, okay, got it. Got it. All right. How about in the computer, or for computers?
If you want to close out a file, it says save yes or no. So it
Got it.
prevents you from. Yeah.
Got it. So it asks you if you change the file. It asks you if you want to save the changes.
Yes.
Okay. I mean, sometimes I think with Microsoft things, even if you just open and close them, it's going to ask you if you want to save, which is really annoying because a lot of times it has me wondering, did I even do anything? Oh. All right. And Steve, what was your example for computers?
Similar, when you try to delete a file or a line from a file, and there's a prompt that comes up, I say, are you sure you want to delete? This might be a permanent, I
Yep.
can't restore, so it's a warning.
Okay. Excellent. And Tammy, how about you?
Mine was along the same. Mine was along the same as the first one of saving the files. But then also I thought, like, is something like an antivirus software applicable too?
Yeah, absolutely. Yeah, it prevents things from coming in the first place. Error proofs keeps people from putting things out there and in different places. Yeah, computers are really rich with those. I mean, if you think about it, like like a lot of people ask me the distinction about like well, what about making it so that you can't do it right? Right? Because the first thing was can't do, and then the second one was make it so that there's only one way. Well, a great example of that is like, let's see, make it so that you can't do it. Control-Alt-Delete is kind of like that, right? So you're preventing somebody from, I don't know if you remember the old days of the PC. I'm old enough to remember using some of the earliest PCs when you could just touch on that on-off button and it would be gone. It would turn off your computer. That was it. And now you either have to hit the Control-Alt-Delete, which is you have to hit 3 keys at once to make that happen, which is difficult to do by accident, or you have to hold down the on button for a long time in order to make that hardware stop. And a good example of one way might be the state drop-downs. So that prevents people from entering in all sorts of types of data when you ask for, what state do you live in? If you're buying something on the internet or whatever, they'll ask you what state you live in, and you don't get the chance to write in New York or Florida with a capital F or with a small f or put in FL. You only get to go in that drop down and pull it down. And that's an example of one way. I could still, if I live in New York, I could still pull down Florida and choose Florida for my address, and that's wrong. So I've done it the wrong way, but there's only one way to do it. Okay, so that's kind of the distinction there. And even the feedback too. The feedback is a good one as well for computers. I mean, what happens if you forget to put in a phone number and that's a required field? What happens when you're filling out like an internet form and that happens? Let's say you're buying something.
Or you may get like missing information, or it just won't accept it.
Right, it doesn't accept it. It usually comes back and has maybe a red box around it.
Button. Yeah.
It tries to give you some feedback on that. So those are all good examples of how people have done error proofing. All right, now the big one at work. So I'll give you a really dumb example from me. We have my business partner and I, we have, among other things, we have a daily sales meeting now. And we have in the past used, out-of-date spreadsheets. We don't have anything to manage fancy. We don't have a fancy CRM or anything like that. And that's we waste our time if we do that, if we're using the wrong spreadsheet. So we have a protocol, and we share things in the same folder in Dropbox, and we have a protocol, for using that and dating the files, and so we can always tell that we're using the one that's at the same date. We also have an agenda when we start it that has to have the date on it. So anyway, so that's a error proofing that we've done on that. All right, so what are some other examples in your work where you have or could error proof something? Tammy, do you have one?
Our front doors are automatically locked, our glass doors at our reception.
Sure. So you can't, there are people, in theory, that helps keep people who aren't supposed to be in out, right?
Correct.
All right, so it's a safety thing too. All right. Steve?
Yeah, one example I see is when you're working with electrical connectors, most of them well-designed when you can only plug in one way.
Yes. Yes, or either they design it that way or they design it to be universal. You can plug it in any way, but it doesn't matter. Like well-designed power supplies. It does well-designed power supplies for laptops. It doesn't matter whether you plug it in upside down or not, because it's the same. They've taken care of the polarization issue already. Yeah. Good. And John?
Fairly simple, but Dan reviews files before I send them to corporate.
That's great. Love it. Love it. That's a great one. I know for one group that I managed, not too long ago, they had to deal with one of their major issues was that they didn't get along with sales, and sales was a corporate function, and we needed to get along better with sales. And so our solution to that was that anytime you send an email to sales, you have to read it aloud. And we all practiced doing it so that we could tell, is the tone right, is the grammar right, but mostly is the tone right, because it's amazing when you read an email aloud before you send it, you find all sorts of things like, that does sound kind of nasty or whatever. Good, good. And it looks like somebody else has joined us, Mike.
Yes.
How are you feeling, Mike?
Not too bad. It was quick and painless.
Oh, good, great. Glad to hear it. Okay. What's that? Okay. All right. So we're in the control phase section, and we're finishing up on error proofing. So that's pretty much it on error proofing. If you want to star one page, I would suggest starring 11, because this is sort of like if you're putting on your goggles for looking for where error proofing can happen, and a lot of times this can help. Okay, I do want to talk a little bit about visual management. There's two things in here. Now, visual management, there's a lot more to it, but the idea is essentially if we can see the errors, if we can visualize, where bottlenecks are, and where our people are, or where our products are, where our processing is happening, it's so much easier for us to manage it. If we can visualize waste and inventory, so much easier to manage it. And it's also, to make it socially obvious to people in a group, so that we don't have to waste a lot of time arguing about data or whatever. So there's just a couple of tools, and I want to take you through this one. I'm sure a couple of you have seen 5S. Now, there are some great demonstrations that you can do live together with a group in 5S. But essentially, this is a really simple tool for managing and organizing a work area. Has anybody seen hoarders that show hoarders?
Yeah.
Yeah, okay. I watched about maybe 10 minutes of one episode. It gave me the creeps so badly that I couldn't watch it anymore. But if that works for you, think about, how would you tackle, organizing something like that, or maybe how would you tackle organizing for a lot of people it's their basement or it's their garage. So if their garage is not efficient, how would you make that more efficient and organized? Anyway, the steps are pretty straightforward. 1 through 5. The first thing you do is you say, okay, I go into my garage. We'll use my garage as the example. And, there's a lot of waste there because I might go in and I might know there's a tool that I want to use. Let's say I'm fixing fixing my toilet, and I know I need to get a spud wrench, and I know I bought one. So I go into my garage, I'm looking for that tool, I spend 45 minutes looking for the tool, I don't find it, I find lots of other tools, I think about using those tools, but in the end I decide I'm going to go to the hardware store, I'm going to buy another spud wrench, and then 5 months later, when I have to fix the toilet again, I'm still looking for that spud wrench. Maybe I find the previous one, or who knows what. It's very wasteful of time and wasteful of goods as well. So here would be the way that I would tackle that. So you go into an area like this, and you say, okay, the first thing I'm going to do is I'm going to sort it. I'm going to take every item and I'm going to put it in one of two piles: keep or get rid of. And I mean it. If I'm going to get rid of it, it's going to be out the door. All right. Now, a lot of people don't like doing that, and emotionally, you may have to have a third pile that's maybe. Okay. So now you have keep, get rid of, and maybe keep. The problem with that is that everything ends up in maybe, but at least you get a few things that are in get rid of, and you have this big pile that's in maybe. And when you go through that exercise, then you say, okay, now that we've done this, now we have to take the maybe pile and put it into one of the others, either keep or get rid of. All right. Anyway, that's a great first step. The second step is to say, okay, now that we've decided to keep things, all the things that we keep have to have a place where we keep them. So if I'm going to keep the basketballs, I have to have a place where I keep the basketballs. If I'm going to keep this spud wrench, I have to have a place where I'm going to keep all spud wrenches, okay? All right, and now that I've done that, and now I've put everything in its place, now I'm going to clean up. So by cleaning up, there's two things that are going on there. One is, by organizing things, I've uncluttered things, and now I can see, like if it's my garage, I hope I'm not going to gross anybody out, but yeah, I probably just found a dead mouse in the corner and some oil spots and a ton of dust bunnies and maybe some nuts and bolts that are all, I'm going to clean all that stuff up. And I'm going to create some emotional baggage for making it dirty again. So that now when I just throw my stuff in there, I've created some emotional baggage. So that's what the third thing is about. So sort it, get it in order, and then clean up. All right, now most people and many companies are good at doing these three, but they don't do this and they don't do this. What's the difference? Well, if I want to go through this, that's kind of like spring cleaning, right? And that's great and it's wonderful, but for a lot of us, every spring we have to do a lot of work. And I don't want that. I want to have the benefits of having it efficient throughout the whole year. So in order to do that, I need my daughter to put have my daughter put the basketballs where the basketballs are supposed to be, and I need her to put her stuff where her stuff is supposed to be, and my stuff where my stuff's supposed to be. When I go in, I need to have her stuff go in the right place as well. If I find her socks on the floor or whatever, they need to go where her socks are supposed to go. So if she's not doing it. And we don't want to get into that whole behavioral thing right there, but at least when we're cleaning up, we put the things in the right place. Okay, so that's what standardize is. It's not just about me, it's about everybody who uses this particular workspace. And finally, the last one, sustain. This is really about monitoring. This is really about monitoring. Make sure that people are doing it. Every period, every once in a while, or auditing. Every once in a while, we're going to check to make sure everybody's on the same page. Or maybe, we don't have any basketballs anymore, so we don't have to have rules about where the basketballs go. We just decided we're going to get rid of them. Okay? So hopefully that example makes some sense. And a lot of companies find that there's a lot of benefit in using this simple tool and using this simple process. Here's an example. A lot of physical workspaces can have these sorts of things. So there's your grandpa's tool hanger, right? Where you can tell instantly what tools are out, and what tools are there, and where they're supposed to go. There's some color coding for other tools, and you can see where like the brooms and dustpans and the long broom is, and maybe where a waste bin is, and so there's something that's missing there. Don't know what. But it's not necessarily just applied to manufacturing. You can also, whoops, I thought I had another picture, and I don't. But you can also apply it to, say, desktops, right? Now, mine's a little bit messy, but you can see right now I have some sort of order to this. And I think I talked to you about this before, about how I have a temp file and where the temp things are going to go. These are all temporary. As soon as our lecture today is over, these all go in the dust bin. And so I have all the space that's available to work, and helps me keep that. But other things like email boxes, inboxes, shared drives can benefit from using 5S. It's really a nice process and a nice tool. Okay. All right, and I want to finish up with talking about visual boards and kind of what they are. So all visual boards are either posters or whiteboards that can communicate vision, goals, current performance or whatever. Now, in the old days, we used posters and we used chalkboards and whiteboards, and that's still okay. I sometimes really do go old school with companies because I like them to actually feel the data that they're plotting. Here's just an example of maybe a functional group may post something like this in their area. Maybe a description of who the group is, a mission and a vision of what they're doing, high-level process of what they do, maybe some photos of their work samples, some metrics and how well they're doing. These could be things that they take a computer snapshot of and tape up, and then some current activities that they're working on. What are some actions that they're working on? Maybe some inventories. They have that. That can be helpful. And this is just an example. It's real nice to be creative with visual boards. One company that I had a star chart, and the star chart was simply they would put up stars for people who were the people that they wanted to recognize that month in their group, a little bit of bio on them and all that. I encourage that stuff too. It's good for developing camaraderie. Other people would have like single charts up on their visual boards, and that's okay too. Show you one example, and somebody was putting their accuracy, and they had other things. They had maybe one other plot that was there, and they would have their goal, and then they would have their they would have not their month to date, but they would have their dailies. They would have their dailies. Maybe I'll plot the dailies. And then they would have their month to date number, which would be plotted like this. So this would indicate, for example, that they're doing, and I used unfortunate colors here, but this would indicate today that they're actually in the plus side. So this would be good, right? That would be good. If they were below it, there would be other things that they could communicate. And of course, then they'd want to connect these with to make the time series plot. And again, I'm using an unfortunate color, but I hope you get this. I'm not going to spend some time doing that. So that would be one example. And they actually used a whiteboard and used these little magnets that they could draw on to do the axes. And so they could put them up there and the goals. And they actually plotted these points by hand and redid them every month. And in that way, they could get everybody involved in physically going up there, and they created a workspace where they could all meet for their team meetings as well. So they used it kind of as a rallying place. That was kind of nice. Other companies may use TV monitors or flat screen monitors are cheap these days. So there's lots of good integrated ideas there. But I like the idea of going old school and not using over-the-top technology sometimes. And you create something simple that people use their body to put things in, and that can be a good way to at least get it started. So anyway, I encourage this sort of thing. Do you guys have visual boards in your, or visual, how do you use visual management in your work? Or maybe there are ways that you could use it more. You guys have examples of that?
Oh, go ahead, Steve.
Okay, thanks. I have a board that I maintain with KPIs on it, quality indicators. In some of our work areas where we've done 5S, we've got them to start using a whiteboard to keep track of orders. The board is very simple. It just lists the order number and the due date and the customer.
Okay.
And the area supervisor maintains that.
Got it. Yeah, and I like that idea of like having everybody maintain their own area, right? Because then they can take some pride in that, and they're showing it. People are going to be able to walk by and see it if they see an old order, or something like that. That's good. Good. Tammy, you were going to share an example?
Yeah, I was just going to say we have kind of like this visual board layout as your example in our call center area. We have, they do like the average speed of answer, the accuracy, that kind of stuff. They have a little board there, and then we also do something for claims because they have, the time to process and the accuracy and the performance as well. So we have little boards and claims in our member service area.
Good, good. And are these things that are kept up to, like, every day do they fill out what their speed of answer was that day and what it is monthly?
It's not every day. It's, I would say probably twice a month. It's for sure monthly, but then he goes back and puts all of from the months before. But he tries to do it every 2 weeks.
Okay.
So, yeah, it's about as updated as it is.
Right, right, right. Okay. Yeah, I know an IT company that, or an IT department within a small company. They take up half the company, so it feels like an IT company, where they manage all of their Scrum meetings. They're really into something called Agile, which is a methodology that IT programmers use these days, or IT teams use these days to make sure they're managing all their projects. They do that all very visually, and they basically show it to everybody in the company. So anybody who, has their project, they should know, the status of where their project is every day, and if it's getting behind, they can see it. And
yeah, our IT team does that as well. They call it a sprint. They're sprints, and then it shows like the sprint 4 for 2015 is, this 2-week time period. This is everything they have on their plate. After it's prioritized by Carlos, I, and a few other people, they go through and on our SharePoint system, people can see where it is and when one person's done with it and it goes to another one. And then, once a month it's reported and shown to everybody, the higher-ups in a meeting, but it's also shown progress on our intranet so everyone can see where their project is at.
yeah, and that's fantastic. That's great. And in fact, that's awesome. In the company that I was talking about before, we did where I said we went old school. We did it visual board and we did it manual. IT was an issue with this particular company and getting them engaged in the business. And one of the things that they saw was how often management went over to that visual board, and they thought it was pretty cool, but then they said, well, we want one of those visual boards, but there's no way we're going to do it manually. So that was kind of a challenge to them and a point of pride. And so they did their visual boards. This was a different company, but they did their visual boards, an automated one. And so then they helped the operations do it, automating it as well, which is pretty cool. It was one of those things that ended up being a real bonding item with a little bit of good-spirited competition. So that's great that it's available on the intranet as well. Now, do you have it visually within the office up, or is it just on the
up somewhere?
Yeah.
No, it's not.
Yeah. So that's something I also highly recommend because that's it's something in the workplace is something that everybody can see, take pride in.
Yeah, and it's catching too. I mean, a few different departments, like, it's great for project. We're trying to implement for our projects as well.
Yep.
And get it all in there, so it shows everyone can just go out and look at and see, how long before they're going to come knocking on my door for this or whatever, that's needed. And then also, like, even our marketing team uses it to show when they've got to have all of our stuff out,
Right.
Whether it's announcements or whatnot or press releases or wherever, they've got it all. Theirs are all in sprints too.
Right. Excellent. Excellent. Okay. All right. Well, that's what we covered I wanted to cover standardization and all that in this. We talked about error proofing. We talked about standardization. We talked about 5S. We talked about visual board. I'm going to move on unless we have any other comments, but all these things I'm a huge proponent of visual boards. I just love them, so I could go on way too long with that. But I'm going to suggest that we move on into monitoring, and I'll leave this for you to fill out. And I think we'll talk about this in control plan we have a little time, we'll talk about optimization, but we'll see. So let's move into process monitoring. And like I said, the goal here is to think about, the goal here is to think about, I've had a lot of people go through and they get, oh, I understand using a control chart. I get it. And in the measure phase, they do their control chart. And again, I've picked an unfortunate color. There we go. And they pick the control chart, and they know this whole thing about special cause and common cause, and it all makes sense to them. There's the thing we need to investigate. But the real key is to be able to put it into practice here, right? When you're here, you want to operationalize this so that you're giving it to a team, and this is what they do. They're making decisions on a daily basis and saying, okay, I'm good. Let's keep going. No need to change things. No need to change things. No need to change things. Uh-oh, we need to stop right now and figure this out before we go any further. And it's really almost that simple, is to say that when we institute that, that's really what we're talking about. There's one other thing that we can think about, although it doesn't always work this way. I want to be clear on this. It's not always necessary to do it this way. We have KOVs, and these are sometimes called KPIs, okay? And we have KIVs, key inputs. These are called inputs. I mean, there's languages. These are called outputs, etc. Part of DMAIC is understanding how we can transfer our management of a process from the outputs to the inputs, right? So there may be some times where we have leading indicators that we can make control charts of rather than lagging indicators. So those are the two thoughts. Is one, how can we operationalize this thinking in the so that in operations we're using it at the time that we need to make the decisions, and then how can we also think about things to, instead of monitoring our outputs, right? How can we monitor our inputs so that we catch things before we see problems before they manifest themselves with the symptoms that are related to our KPIs. Hopefully that makes some sense. So this is all about control plan and monitoring. And I think what I'd like to do, I think I've said all of this, and you can go ahead and read this or listen to the video, either one. But I want to go through an example of that. And the main thing is, I guess, just to put a bow on it, how to control charts on, if we're talking about two different things. One is we're operationalizing this, right? Here's our output. The first thing is we're operationalizing it. And the second is we're maybe going to this side. Okay, so the questions might arise. How do control charts on inputs differ from those on outputs? The answer is basically not at all. We use the same charts. If you were using a P chart before and a P chart makes sense to use now, use a P chart, okay? You interpret data points the same way. However, the key differences are usually when you're looking at an input, you usually sample a little bit more often. So you're sampling at a faster rate. If you're sampling an output once a month, you're sampling an input maybe once a week or once a day. Because we're trying to keep things in control, right? And that makes sense. If we're looking at a leading indicator, let's look at it often enough so that we can catch problems in the bud. The second thing is we usually use fixed control limits. What does that mean? That means I don't always use all of the data prior to that to calculate my control limits. I have a period where I calculate control limits, and then I freeze them, and I fix them, and I say, okay, let's say my upper control limit is 5, whatever that means. I fix it at 5, and 5 is the control limit that I don't want things to go over anymore. Now, I can change that at some point when the process changes, and I'm sure there's been a real process change. Like, for example, there's a further improvement. Maybe you further tightened up the process. Maybe that 5 needs to become a 4. Great. Go ahead and do that. And for that, and make sure everybody understands what it is in the new situation and go forward on that. But you freeze the control limits. And usually you develop an action plan to go along with the chart. So if I have a plan where I'm looking at this and I say, okay, here's the chart that I'm using. Here are my fixed control limits. And okay, I just got and I'm using it, let's say this is daily. I'm looking at it daily. This is my variable. I'll just call this I'll call it a KOV, but it doesn't matter which one. I'll just call it Y. How about that? Leave it generic. And whatever date this is, let's say this is May 2nd. Okay? Oh, we went out of control on May 2nd. This last thing just says, what do I do here? What happens when I get an out of control point? And so once you've gone through a domain project, you should have some idea of some advice that you can give. The simplest advice would be, here's a phone number and an email for somebody that you need to call when it goes out of control. That's the simplest thing. But it could be related to the errors that you found or the root causes that you found in the analyze phase. You could give somebody a troubleshooting guide to say, first do this, right? This is the first thing that you need to check. If this thing is not working, if your computer's monitor is not working, first thing that you need to do is look to see whether it's plugged in. The second thing you need to do is to look to see whether it's turned on. That might be an example. The third thing that you might want to do, if those two things are, if it's turned on and it's plugged in, is to call Joe, and Joe's going to come over and fix it. Okay, great. That might be your troubleshooting guide. All that makes sense? Hopefully. All right, so let's do an example, but I don't want to do this example. I want to do the example that is in the exercises. So right here, suppose we have an auto repair shop that went through D, M, A, and I, okay? And now they're in the control phase. This is where they are. They found that if they keep within, typo there, within their typical schedule, they can service most customers quickly, thus reducing the time that the customer is without a car. Ooh, that's nice. They're actually trying to minimize the time the customer is without a car rather than minimize their labor. That's nice of them. Okay, so let's go through. What would be some leading, if they're trying to, so their key output variable is this TWC. Oops, and I've got black there, so that didn't show up too well. But that's my output variable. What might be a leading indicator that you could measure that would maybe indicate whether this time without a car is going to go out of control, whether it's going to get bad? What might be something that you could use?
Backlog?
Backlog. So I might periodically measure how many jobs do we have in backlog. Good. That's great. Any other thoughts? Okay. Let's say. Go ahead.
I'm thinking of weather, like in the cold regions. If there's a lot of snow or ice, where people may get into more accidents or need more repairs.
Okay, that might be, but that would only come out if you found that weather was a key driver. If you didn't, there's no way you'd use that. Why did I say backlogs was good? It's because of this little tiny bit of information. If it keeps within schedule, within its typical schedule, right? So that's why I said if we can look at backlogs, backlog is an indication that we're not keeping within schedule.
Okay.
Does that make sense?
Yeah.
So what I'm saying is not a bad idea at all, but for something like that, we'd want to make sure that it's related to things that we found in the analyze phase. Good. Very good. Okay, so let's say that we went with backlog. So, John, how often would you measure it?
You should probably measure it at least daily, or I don't know, even, I mean, depending on the size of the shop, hourly. I don't know if you could visually do it, or maybe even hourly, really.
Yeah. So again, it depends on what the shop is, right? So if this is a local shop, which it probably is, right? You're probably going to want to measure it. You're probably going to look at it, monitor it very quickly. So you've got to have ways that you can look at. You've got to have ways that you can measure it very quickly and efficiently, without having to, overburden a labor force, right? So those are challenges that you'd have on this. Good. Good. Both all good stuff. Let's now do an exact thing here. Let's suppose that instead of John's example, they use something which I think is a little more cumbersome. And I wish I would have just said backlog, because that would have been a better idea. So they created a variable called time behind schedule, and they're going to do it not once every hour, but once every 2 hours. And here's what they're going to do. They're going to randomly sample one started job. They're going to see when it finishes. They're going to wait till it finishes, and then they're going to see the difference between the time it finished and when it was supposed to finish. Okay? Now that's complex. So that's probably not a very good measurement, but that's what they did in this fictitious example. So, for example, suppose a job that was selected was scheduled to finish at 3 o'clock. If it finished at 3:08, it would get 8. If it finished at 2:54, it would get -6. So, in other words, if it finished ahead of schedule, it would get -6. If it finished behind schedule, it would get 8. So, how would you go ahead and set the control limits then for that? Well, what you would do is you would go out and you would collect some data on this, and you would say, okay, when the process is in control, let's get some data for when the process is in control. So, we all know that we're never going to finish every job exactly on time. We want to get a feel for how much it varies, right? Maybe go out and collect 30 or so data points, and then we would do the following, okay? Then we would actually go ahead and we'd calculate the limits. So I just want to make sure that we're all on the same page with this. So I'm going to go ahead and calculate the limits for this. And here's my time behind schedule. Whoops, whoops, whoops. I need Excel stats open. And you get to lovingly see how much I put into doing the control chart again. So we're going to use an eye chart, right, because it's a continuous data, and that's the chart that we're going to use for continuous data. I'm going to clear it all out. There, it's all clear. I'm going to go back to my data here, and I'm going to copy it. And go back to my spreadsheet, and I'm going to paste it in. My data have a header. There it is. Okay. So this is my data that I've got, and it shows, what are these negative numbers? Should I be getting negative numbers?
Yeah.
Yeah.
Yeah, I should be. Those are jobs that finish early, right?
Right.
So if we take a look at this, typically, does this company finish a little bit early or a little bit late on its jobs?
Late.
A little bit late, right. But, if they're finishing about 5 minutes late, not such a huge deal. And we might fix those limits. So here I've got a calculation. It says my upper control limit was 24.9879. My center line is this, and my lower control. Where would you set the upper and lower limits on this if you were running this shop? I mean, what would be the...
Okay. That's tolerable to the customer on the upper limit.
I'm sorry?
On the upper limit, you'd like to know what's tolerable to the customer.
Yes, you would, but is this voice of the process or is it voice of the customer?
Right now we're at process.
Right. Right, so if we've already run the improvements, right, we've already run the improvements and we're trying to monitor it, we're trying to make sure that it's in control. We're not trying to keep an in-control process if it's not good to the customer, right? So, I'm with you, but let's not mix our apples and oranges. Use control charts to monitor the process, not the customer, okay? That make sense?
Yeah.
Yeah. Yeah. So for control charts to be used effectively, we have to have a process that's pretty good. So ideally, this should be within. We know the customer's not going to be happy necessarily waiting a long time, but it's not going to go really haywire. The things that we really want to avoid are apparently the client being an hour late or whatever. So here are some thoughts. You might want to, for example, fix it at 25 minutes. Now I just made that up, but having it fixed at 24.9 whatever, that's not going to help you. You might want to fix this one at -10 or -12, whatever. And this way you can language it to people pretty easily. So something that's lower than -10, it shows you we're getting ahead of schedule, and maybe we can do better than we are right now. Maybe we can manage our schedule a little bit better. It's possible that you might want to choose something like 20 and 10 and -10. But in any event, use something that is not, don't put in these calculated limits. Figure out something that's pretty close and you can operationalize. So that would be just kind of my simple-minded advice there. Okay, so I'm going to remember this 25 and -10. And doing that should help us stay in control, or know when we need to take some certain action, whatever that action might be. Bring in an extra person, or whatever the actions are. And that, I think, is going to the point that you made, Steve. Let's suppose that we were going to bring in an extra person. That was our troubleshooting guide. If we got really behind schedule, if we were only 20 minutes. If we're 20 minutes behind schedule, we wouldn't want to make that call to bring in somebody else, because that's not that rare. That still is indicating a fairly in-control situation. Now, if it went to 26 minutes or 30 minutes or 40 minutes, we would definitely want to go through with whatever action that was. Okay. Let's see if we can get back to the third part. Okay. Now let's get back to this, and I'm going to take that down. Okay, so here's the question. Would we, and I'm going to kill two birds with one stone here. I'm going to open up our control chart template, which is conveniently not on my bar here. Okay. And come into here. So we'll cover this very shortly in terms of what's in there. But this is in your templates directory. No, let me just pull this out. Yeah, that'll do it. Okay, so this is in your templates directory. We have a control plan that's in there. And one of the things that's in the control plan is a template for a very poor template for a control chart. Okay, so what you can do is you can actually just type in what you want as your upper control, what your lower control is. I think we said -10, and what the center line was, and I'm just going to put 6 in there. Okay, and I'm just going to copy that down. And I'm sure there are better templates, but sometimes I need to make things in Excel. And this is a fairly easy way to do it. I need to change my axis too. So let's go to -15 and 30. There we go. And whoops, I need to label that too. Let's make that 10 and 5. Okay, so all I really did, I probably want to move this to the bottom as well. Let's see. Vertical axis, okay. Oh, that's not it. I want my other axis. Oh, well. I'm not going to worry about that right now. Okay, and so we can take a look at this in terms of, what would you recommend for the service center? April 17th at 2 o'clock. They measured 10.3 minutes. What would you recommend they do? And I think the answer is what? Should they stop the presses, or should they just continue going on?
Continue going on.
Yeah, don't do anything. They're behind 10 minutes. Don't do anything. It's okay. It's not an out of control situation. At 8 o'clock on April 18th, they're 5 minutes ahead. What should we do? Well, It's probably the same answer, right? Don't do anything. Okay. On April 18th, however, at 12 p.m. or at noon, they're 48 minutes behind. What should we do? We should do something, right? Whatever the prescribed action is. And I guess I should have really opened this up to like 50. There's our out of control point right there. So we should do something. And this is where we should take action, fix it right now, and so forth. You see, the point is I'm trying to make here is that these data points are coming in as you're measuring them, right? So they get plotted on the chart, and you evaluate them, point by point. Let's say you get back into control, and a couple days later you're at 16 minutes. What would you do? 16.5. Okay, again, this is a don't do anything. Don't get your. Oops, I said something badly there. Don't get upset or don't go into a tizzy. Just keep managing the process as you are. Okay, does that make sense? Hopefully that makes sense. It's easier said than done. It's easier to get people to not. It's easier said to get people to not react to points like this than done. But I'll tell you, if you give somebody a tool like this and they're plotting points and they see them coming up, and you give them the idea that, look, if it's outside that red line, I need you to call, or I need you to do this, or I need you to take care of this, it will happen. So you can use this to help reduce firefighting. Okay. Now, some pitfalls in doing this are there's a couple of pitfalls, and I want to make sure that you hear about them because I've fallen into them. Just so that you know, here's one of the pitfalls. One of the pitfalls is that I made a fix, and I didn't take enough data, and I ran the data over a very short period of time, and over that short period of time, my process was pretty tight right after I made the improvement. So it was like this, and I got control limits that were, say, like this. Well, when I went into production, I wasn't really paying attention. It turned out, there's lots of different people that were monitoring this, and there's more variation. So make sure that you give it enough time and put it in production. Otherwise, you're going to have, it almost looks like I did a better job here. This would have been set tighter. But make sure that you don't create limits that are too tight. And just watch it. So I would say, the first few weeks, you want to go in, you want to talk to people about how they're using it, and you want to monitor how it's being used. I would say that's pretty critical for control phase stuff. Okie doke. So that's definitely a pitfall. If you create things that are either too tight, where every day is out of control, if every day is out of control, people will soon ignore the warnings. The other thing that you can do is create limits that are so wide that a truck could go through them, and you want to watch out for that too. The big thing is just to kind of monitor that and make sure that this can happen to anybody. Use some data that ended up not being representative of the process and how it normally operates. So just look for that. Those are things to look for when you put it in operation. Really nice thing about individuals control charts, though, really nice about them, is that each of these data points is a measured data point that you can point to and say, here's the data that we've got from this. In a lot of the other charts, C charts and P charts are also very close to that as well, so they're nice properties. In the other charts that we didn't talk about that you will sometimes get arguments for using, you've got averages, you've got weighted moving averages. Those are tough to explain to people. So people will understand individual control charts. They'll get it. All right. Questions or comments on process monitoring? Okay. And I do want to talk a little bit about control plan. Mainly, I think we've already talked about how a control plan is really sort of it's the heart of the control phase. It's the heart of the things that you do to put together into the control phase. It's the place where you It's sort of like a user's manual. In the old days, it literally used to be a 3-ring binder that I would give. I wouldn't just give to a team. I would work with them to build, but we would keep all different things in it. The things that we would keep in would be process maps. If we did process maps on this control plan or on this process, they would all go in there. Standard operating procedures or policies and procedures, they would all go in there. The measurements and the measurement definitions, they would all go in there. Templates for the charts that we were going to use to continue monitoring. Audit forms if people had those. Again, it's not rocket surgery, doing a control plan, but it does take a lot of effort working with a team and working with a sponsor and a process owner to get it right. When should you start working on a control plan? I hate to say this, but you really should start thinking about control plans really when you're in the measure phase, because you're putting together what are we going to measure, right? What are the things that we're going to measure? When you're in the analyze phase, you're thinking about, okay, what are maybe the other things I'm going to measure? What's some training that I'm going to need to do, that I'm going to need to standardize? And especially when you're in the when you're in the improve phase, you're going to be thinking of what are the things I'm going to need to institutionalize with these improvements. But it's really in the control phase where you're working out those iterations to say, is this going to work so that I can walk away from your process? Because I don't want to own that as a black belt, especially as a black belt. I don't want to own all these fixes. I want you and your group to own them so that I can walk away and I can improve other parts of the business. Because otherwise, if I'm a black belt, I have a very small number of projects I can do if I have to own them forever. I can't do that. And I'm too valuable a resource to allow that to happen. So I need to get a control plan down so that they can manage it themselves. It's really as simple as that. Okay. So that's it. So sometimes it's helpful to think about what's not in a control what's not in something, or what something is not. So I do have this slide to kind of go through. It's not a tool to simply increase firefighting. It's not a way to simply add audits or extra bureaucracy. It's not a list of next steps in a project. Here are the next things I'm going to do. It's not a place to conclude all of your analysis. I know we're all proud of the analysis that we do, but the control plan is not the place to include all that. It's sometimes a don't do this anymore list. Here's basically what it is. It is a list of the key changes, including any error proofing that you've done. It's a list of the monitoring plan, which outputs and key inputs to measure, how they're measured, who's responsible for doing it. It's a corrective action plan. How are we going to handle if it goes out? Maybe there's a troubleshooting guide or a log that does this. It's a guide to who needs to be trained on what and when. So if we found some of the fixes where the operators didn't know these key pieces of information, that's great. They need to be trained on that. We need to monitor that everybody's trained on that. Great. Here's where you put that documentation. It does include lots of documentation, standard operating procedures, workflow, flowcharts, data storage, retrieval, where things are going, maybe phone numbers or emails, and an update plan. When do we look at this control plan to make sure that it's still relevant? Maybe we created some things that 6 months or a year down the line are no longer relevant, so we need to make sure that it's still relevant. Okay? And the thing I like is a single one-page process summary that shows all of these different things. And here's an example on the page, but I've got one better, and that is an example here I want to show you. I already talked about what was on that slide. Here's the example, and we've been using this template, which is kind of nice. I've got a template in here, and you can use it if you want. I think it's helpful. And you can jazz it up. You can do better than an Excel spreadsheet with tabs. But here's my one-page summary, the name of the project, the process description, what date it is, what revision this control plan is, when we're next going to review it, and I say it needs a specific date, who it was prepared by, who it was approved by, what are some key metrics that we're looking at, what are some key charts that we look at, how often do we review this control plan, okay? And then here's a high-level process map of what the control plan, of what the process is. Here's my monitoring plan, what the measurement is. I've called it an indicator. If I have specifications, how I'm going to measure it. You know, do we pull it from a database? Do we go out and sample? Right? With John's backlog example, how do we know what the backlogs are day in, day out? What chart we're using. If there's a sample size, I put that in there. How often I sample this. And who's responsible for it. What's the action plan. That's it. Data storage. Fill out what you need to on this. If you don't need to fill it all out, you don't fill it all out. Okay? A lot of, like if you Google control plan, this is the sort of thing that you find on the internet if you Google it. But to me, this is just part of it. This is just what you're monitoring. You need the other stuff too. Here are the charts. I like to include these things if I can. Here's a troubleshooting guide. This is actually not a guide. It's just a log. You know what the event was, who logged it, and what the notes are, and what happened. Like this is for if we get a point like this one right here on this third day, we would want something that logged that. You know, here's what happened on that third day. Here's our training plan. It's just a placeholder, right? And here's a list for all the changes and to the process and the background on those things that we had. Okay, so it doesn't have to be anything complicated. It can be pretty simple, but it's good if you get a lot of those things in there. If I were going to add something in here, I would say, you know, add a documentation thing in there for process maps, for SOPs, and things like that as well. You can just put links these days, or if you can do it on your intranet, that's even better. Okie doke. So that's it for control plan. So like I said, it's easy to understand and talk about, but hard to do. As I said, creating it, control plan shouldn't be created in a vacuum. Key stakeholders need to be involved early and often. They need to review the plan. They need to know that it's going to be around. You may not be around to manage this process for them. Maybe you can hold their hands for a couple of weeks or maybe even a month, but you don't want to be holding their hands for 2 years. Draft it up early, share it, rework it until they're satisfied. Okay. Questions on control plan? Okay. Well, we have come to the point of, I think, the special topics right now. And I'm happy to keep going, but I think what I wanted to do really is, like I said, these are techniques that you can use in a lot of different places, and they're helpful, but they're really sort of advanced techniques. And I really wanted to kind of walk through at a high level, you know, how far we've come and all the things that we've done. And I think that's maybe going to help to solidify these things. If you'd like to know more about optimization, which I love, by the way, or queuing, or DFSS and Hoshin, I would suggest either you can watch the video, or please, you can call me directly. I'm happy to walk through those with you. These are also topics that we're going to cover in our webinar series. So if you're interested in that, and I know I've talked to a couple of you about that, and Dan, Steve and John, I've talked to Dan about this. We're going to go through, we have a webinar series in our company where we go through special topics like that or things that are requested by people and cover that. We do that like on we do that bi-weekly. We're just starting this out, so we're really looking for customer input on that. And we're giving a demo next Thursday. We'd love it if you could come. That's something separate from this. when we started this whole process, we started in this. We started even just learning what the methodology was, and we talked about define, measure, analyze, improve, control, and we really talked about all the things that we would have to. Starting with define, there were deliverables that we needed each time, but a couple of ideas. First of all, it's about deliverables. It's about doing things for the business, right? Six Sigma is about improving the business. It's not about improving processes. Process improvement is a means to an end. It's about improving our business for our margins, for our bottom line, but also for our customers and for our employees. And when we think about DMAIC, it's about the deliverables, right? These are the deliverables. These are the things that you have to do. They're non-negotiable. I guess I can kind of negotiate on the toll gates, but I like toll gates. I always, in every project, I need to make a business case. Every project, I need to link to the customer. Okay? Every project, I need to make a macro. I need to make a macro map, like a SIPOC or a high-level value stream map. Every project, I need key outputs. Every project, I need a team. Every project, I need a plan. All those are deliverables. How I do that, whether I want to use the snapshot tool that Mark provided or whether I want to use Microsoft Project and do a Gantt chart from that, that's up to you. We did learn a lot of tools like the SIPOC, for example, here, or like the Kano analysis, but you can choose to do those. So I think those are some of the things that we talked about there. In the measure phase, we're talking about once we know what the project is and what the problem is, let's get a baseline. Let's get a baseline for our process. Let's get a baseline for our variables, our key variables that we're looking at. We need to go out and collect some data if we haven't yet. Now's our chance to rescope the project after we take an initial look. Keep it tight so we can get it tactically done, deliver benefit quickly. And analyze is when we're finding out those root causes that really do hit up on our problems that we identified, right? So making sure that we're generating all the potential causes that could be there, and then we're effectively circling the ones that count. Of all the potential ones, these are the ones that really make a difference, and we get to the root causes of those, and those are the things that we want to make the improvements on. Now that we've evaluated the improvements, this is where we generate the plan, generate our solutions, select them, and then plan those implementations, maybe run a pilot, make sure it's working, and evaluate those improvements. Now that we know that they're working, now we want to institutionalize them. We want to standardize our improvements, develop that control plan. And now that we know it's all working, we want to make sure that we communicate what's been done and that we made improvements and that things are better, and think about what future improvements we can make to that. If we didn't get to our goal, but we got halfway there, that's great. We want to take the time and celebrate the successes that we had, and make sure that we maintain our gains, recommend future improvements, and celebrate and acknowledge what we've done with our team and done ourselves. So I think at this point I'd like to, I know this was an extra session that we did because we missed that one. I'd really like to thank you. This is always a lot of fun doing it for me. And I know I'm going to talk to all of you about your projects and things like that, but I really do care that you finish the projects and that you finish them successfully. And a number of you have had a hard time getting started. That's okay. When you want to certify later, that's great. There's no time limit on that one. I'd love it if it happened earlier rather than later, but there's no time limit on that one. So when you do finish, let's talk about that. But anything I can do to help you get started or help you keep going, don't be afraid to reach out and call. So I guess with that, I'm going to stay on the line to answer any questions, but I'd like to thank all of you for attending the class, and I hope you learned something, whether it was multiple regression or whether it was as simple as the idea of a control chart, being able to say, there's a difference between variation that's meaningful and variation that's just, a little bit. And I can tell the difference between the two now, and that's going to help me, manage my actions. That's fantastic. So, so I'd like to thank you all, and I'm going to start the recording and wish you all a great week, and we'll be talking soon.
Thank you, Mark.
Thank you very much, Mark.
You're very welcome. We'll see you on down the road.